His work was carried out in the laboratories, but the key thing was that he engaged with steel plants to be able to bring these technologies into the operating steel plants.
Alexander McLean is a professor emeritus in the Department of Metallurgy and Materials Science at the University of Toronto. He earned his bachelor's in applied chemistry in 1958 and a PhD in metallurgy in 1963 from the University of Glasgow. In 1963, he moved from Scotland to Canada and was at McMaster University for 5 years, first as a postdoc fellow and later as an associate professor.
Alex has been a pioneer in forging industry-academia collaboration.
Because of this activity, many researchers and engineers from industry and the university came from all over the world. Because this success to this activity is the effort of Professor McLean. And I guess we owe him, all of them. As a former student, owe him a lot about the example and the wisdom he provided over the years.
Many of his technical studies revolved around looking at impurities in the steelmaking process: sulfur, oxygen, nitrogen, the generation of nonmetallic inclusions. And he studied various ways to minimize the formation of these, how to eliminate them, or how to control the properties of nonmetallic inclusions by making various additions in the processes that are followed in steelmaking. In the 1970s, there were no secondary metallurgy facilities in the steelmaking operations. Essentially, we went from furnace to casting process. However, if we look at the situation today, what we have is we have a whole realm of secondary processing treatments which enable us to control impurities and inclusions in steel, and to a large degree have been influenced by the work that Alex McLean has done.
Professor McLean once famously used the seemingly backwards construction of a bridge over the Mississippi River in New Orleans, a bridge that stood tall but had no connection to roadways on either side at the time, as an example of the need for strong links between academia and industry. Walls impair people, bridges link them.
It's hard to walk into a plant and not come across a person who hasn't learned from him, whether it's through taking an undergraduate course, doing a master's or PhD research with him, or just attending one of his talks in the seminars and co-workshops and courseworks and those kind of things.
Now, we all know that Alex is a distinguished scholar and that he has won numerous awards. In fact, his contributions to the field of ferrous metallurgy are unparalleled. What sets him apart, however, is his demeanor. He is what I would call the perfect Scottish gentleman. Alex is always willing to help any student and volunteer his valuable time to requests from the industry.
One of the things that you have a difficulty with the first time you meet Alex is you may not be able to understand what he's saying to you. However, once you met with Alex, you realized that he had a passion and enthusiasm for the physical chemistry of steelmaking that even his Scottish accent couldn't disguise.
But also he has a remarkable personal quality. He has a kind and considerate and then very welcoming. And also he is very energetic. He radiates energy. As soon as he comes in his room, his energy radiates over the room.
Alex wasn't alone in this. During his tenure at U of T, he developed numerous graduate students, his disciples, as I call them, who carried this message of control of impurity elements into the steel industry and really have evolved the steel industry to its current state, in which all steel plants now practice some form of secondary metallurgy and or tundish metallurgy.
If I would want to describe Professor McLean, I'd simply say he's a pillar of support.
We all know many excellent academics, but Professor McLean is truly one in a million. He is a fabulous speaker, and he has hundreds of stories about our industry that always bring a tear to my heart. I am extremely proud to consider Alex a friend.